Recording. Okay, so what I did is I took some of the questions from EdReady that you guys either skipped or missed. Not everything's going to be on here, and one of them I will kind of give you an idea of how to solve it, but it's in a past video, so you guys can watch that video on Canvas. I think it's either review 1 or review 2. All right, so the first thing we're going to deal with here is distributive property. When you distribute, you're basically just multiplying. So these distribution properties can be done a couple of different ways, but since they want you to use the distributive property, you would actually multiply the 6 by the 11 and the 6 by the 3, and then the 4 by the 7 and the 4 by the 5, instead of doing the order of operations. So 6 times 11 will give us 66, minus 6 times 3 will give us 18. And then 4 times 7 will give us 28. And then 4 times 5 will give us the 20. Okay. What you will see in 105 more than this will be something more algebraic, where it'll be something like, say, 5 times the quantity x plus 12 equals, I don't know, 15. And you would have to use distribution. But I always tell students too that math is a little bit fun because you can do things a little bit differently. Instead of just distributing, which you could in this case, 5 times x will give you 5x, and then 5 times the 12 and so on. But the other cool thing is notice how our 5 also goes into 15. You could choose to do 5, divide by 5 on both sides, and work your way that way. So I'm not going to do the other 2 on this page. You guys should be able to use the top example. And of course, you would want to continue with this, but you guys can do that. All right. So for this one, for the, I'm going to actually show you what EdReady wanted, and then I'm also going to show you how to solve it. So it says to identify the amount. The amount here is unknown. So the amount is unknown. The base is 485, and the percent is 60. Right? That's how EdReady wanted you to answer it. If I were asking this problem, I would care more about how you solve that. So you're going to take 60%, so that would be 6 over 100 is equal to, when you see of, you know that's the base, so that's the bottom number. So then x is on top. And then you would cross multiply. So 100 times x equals 60 times your 485. Again, I'm not going to finish that because that's not really what the question is asking. And then what I would like you guys to do is take a few minutes and try to solve these 2 on your own, and I will be right back. Okay, so again, I don't know about you guys, but I don't like fractions. So I'm actually going to get rid of this fraction of 1/3 here because I'm going to multiply it by 3 on both sides. So if I do 3, 1/3, 2x plus 3 equals 3 times my 3. These 3 cancel. So you get 2x plus 3 equals 9, minus 3, 2x equals 6. Divide by 2, divided by 2, x equals 3. Okay. All right, for this other one, I'm going to solve for x. So actually x's on both sides, so you're going to bring them to the same side. So I'm going to do minus 7 on both sides. It's going to leave me with a 4x equals 6 plus x. I'm going to subtract the x on this side, subtract it on this side. 3x equals 6, divide by 3, and x equals 2. You could plug both of these in up top, and you should get 3 equals 3 on the for the first one, and 2 equals 2. Well, no, you would get 15. Huh, weird. We did do that right, but that's interesting for that one. If you plugged it back in, yeah, you would get 15 equals 15. Good. Okay. All right. Next one. So this one, unfortunately, you would either have to deal with the fractions, or you can think a little bit outside the box, and you can see that 6 and 3 goes into 6 2 times. So if we multiply top and bottom of this fraction by 2, so basically 2 over 2 will give you pretty much 1 over 1, right? So we don't have to do anything with the other parts. We can use just 2 over 2 to kind of help us out. And why is going to become clear in a minute. Okay, so 2 times 2 will give us 4. 2 times 3 will give us 6. Okay, what you can see here now is that we have a common term. We have a common denominator. So we're going to actually add 1/6 x to both sides. And that will give us 5/6 x minus 6 equals 4. We're going to add 6 to both sides. Get 5 over 6 x equals 10. And then we just have to multiply by the reciprocal on both sides. So this 6 cancels, this 5 cancels. We get x equals 6. Well, 5 goes into 10 twice. So 2 times 6 would be 12. And again, you could plug that in. Let me write it a little bit better. Okay. All right. So that's how you do those kind. We're going to do our first word problem. And it's basically an applied perimeter problem. You want to create a rectangular frame for a picture. So a frame, anytime you see the word frame, you need to think perimeter. Do not think area. And they're nice because they tell you it's rectangular. So that means you're going to have the perimeter is going to be 2 times the length plus 2 times the width. You could have done L plus W, but this is the more preferred form. Perimeter is actually equal to 60 because we know that that is the amount of material that she has available to her. So we're going to say that that's the amount available for the perimeter. And then what we have to decide next is how we're going to get the length or the width to be in terms of one another. So this tells us that Katie wants the length to be 3 more, so 3 more, than twice the width. Okay, and we need to find L. So we need to find the length. So we're going to plug what we know for L in terms of W into the equation. So 2 times 3 plus 2W plus 2W. Okay. So again, we're distributing here. This is more the distribution that I like to use than the one where you can do it differently. 2 times 3 is 6, plus 2 times 2 is 4W, plus 2W. So then if we take 6 away from 60, we'll have 54 equals, and 4W plus 2W will give us 6W. So divide by 6, divide by 6. W equals 9 inches. But the question is that what we were supposed to find? Okay. No, we're supposed to find the length. So if we put the W in for 9 in for W, 2 times 9 is 18. 18 plus 3 is 21. So L equals 21 inches. And then again, to check, you would just plug the 9 and the 21 into your perimeter and see if you get 60. 21 times 2 is 42, plus 2 times 9 is 18. 42 and 18 do give you 60. So it does work. Okay. This one, I just wanted to talk about. At least one person missed this. So what you would have to do here is you would have to figure out your solutions, right? You can do this a couple of different ways. This is obviously the correct answer. You would have had this column and this column with nothing in between. And you would have to put in the lines. So you could choose to kind of plug and chug in a way. But if you did that, you would notice that for this one, 5, 0, and 0 would both work. If 5 and 0 both work, then that means everything would work, because that says all real solutions. Okay. The other option is to just solve it. So I'm just trying to see what some of the differences are here. Okay, so we have a plus 2x and a minus 2x on sum. That's some of the differences. And then on the right-hand side, you have 2 positives and then you have 2 negatives. Okay, so I'm just going to do the first one, just because this is such a long set of problems, and then you guys can work on them as well. If anyone needs more of them, let me know, either via email or in a check-in. I can pull these up anytime, so. All right, so 5 times x will give us a 5x minus 2 plus 2x equals 2x plus 10 plus x. So let's see, that gives us a 7x minus 10 equals 3x plus 10 plus 10 minus 3x. That gives you a 4x equal to 20. Divide by 4, divide by 4. X does indeed equal 5. Okay, so that's how you do that kind. All right, the car rental. Here's some key things you have to pull out about the car rental. The initial fee is $52. You have an $8 per hour charge, and the available funds are $144. So if you set that up as a function, you have $8 for every hour. an initial fee of 52, and the availability of 144. So if we take 52 away from 144, we get 92 divided by 8. We would get H is equal to 11.5 hours. But here's the thing. It tells us that the car cannot be rented for a partial hour. So the max hours would be 11. Okay. All right. Okay, so this is evaluating using some exponents. So if x is -1, what would this equal here? Well, -1, the whole thing is cubed, minus a -1. Anything raised to the 0 power is 1. Right? Yeah. Negative times a negative gives you another +1. -1 cubed, -1, -1, -1. So -1 times -1 is a +1. +1 times a -1 is a -1. So 2 minus 1 will give us 1. Okay. Same thing here. What does x cubed equal when x is -3? So it's going to be a negative, and then 3 cubed is 27. Okay. And then 8 to the -4th, when you have a negative in the exponent, you get a fraction. So it's going to be 1 over 8 to the 4th. And if we get our calculator out, 8 to the 4th. Wow. 1 over 4,096. But I think you can leave it like that. I'm not sure how EdReady would want it, but I think they prefer that version. But both are correct. All right. Again, if I'm going too fast, just let me know. Okay. All right. So the next thing we're going to do is a little bit of geometry. What you had to do here is you had to identify all the points and line segments. So the points are easy. They can be identified with just a point. So points are A, B, C, and D. The line segments, they are AB, AC, AD, CD, and CB. Okay. This semicircle and square area and perimeter, that's the one that I said I did in another video. So basically what you want to do is you want to find the area for a half circle and add it to the area of the square, and you'll add those together. And then the perimeter, it's half the circumference plus the perimeter of the square. Okay. Right. Last one here was requested. It is a system of equations. So it says A theater sold 1,125 tickets for a musical performance. The orchestra seats cost $40 each, and the balcony seats cost $25 each. The theater collected $39,000 in ticket sales for the performance. How many orchestra tickets were sold? So orchestra is the $40. All right, so this is what I did. First thing you have to do, I did my let statements. So I said, okay, X, we're gonna let X equal orchestra and Y equal balcony. Okay. All right. So then I said, okay, orchestra is, so we know that the tickets together will be 1,125 tickets sold together. We know that orchestra tickets are $40 each and balcony tickets are $25 each, and that the total sales was 39,000. Okay. That is our system that we now have to solve. The best thing to do is solve for one of the variables. So in this case, we care about the orchestra, so that's X. So if X equals, now we just have to move the Y over. So 1,125 minus Y. We're then going to place this into the other formula, into the other equation. 40, that's 1, 2, well, too many ones. Okay. Now, here's where you can mess up. I definitely put a 4 here. It is a 40. So just pay attention to what you do. All right. When we multiply here, we get 45,000 minus 40y. Now, initially, you're going to think, oh, I have negative numbers. I'm doing something wrong. Well, the negative numbers are actually going to end up canceling. So don't worry about it. Also, don't do what I just did, which was drop off the plus 25y. So let me squeeze that in there. This is why you should all do your work in paper and pencil on paper. All right, so we're going to subtract the 45,000. When we do that subtraction, we're going to end up with 40y plus 25y equals negative 6,000. Again, don't be afraid, because when we take our negative 40 plus our 25, we end up with negative 15y equals negative 6,000. So we divide by negative 15, divide by negative 15. So y is equal to 400. If you take 400 away from the 1,125, you end up with x equals 725 tickets. And that's the one you cared about, 725. You can check it by plugging in 725 and 400 into both equations, and you should get the same results. Okay. All right, for the sake of the video, I'm going to stop there.